See, these are all possible by installing different types of cameras at different locations of the city. We can use this in different types of industry where the user will be benefited more. Now, what are all the resources we are going to connect to this grid network? It is called as nodes. The owner has only the private key who has the one started transaction. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysore. Students, let us start our discussion with the topic emerging trends. And in this session, we are going to talk about the technologies like smart cities, grid computing, blockchains, and cloud computing. Now, let us start with smart cities. Now, what is the definition of smart cities? See here, the idea of smart city is make use of computer and communication technology along with IoT to manage and distribute resources efficiently. Now, this is a definition of what is smart city. So, what is the meaning of this? Here, it is nothing make use of computer and communication technology through IoT. So, with the concept of IoT, Internet of Things, it is possible to manage and distribute resources efficiently. Now, if we talk about resources, is nothing but resources of a city. Suppose if we talk about resources of a city, it is nothing but different government departments like water supply department, electricity, drainage, and power system, and so on. So there are different government departments. They are nothing but resources of the city, and all the people of that particular city are eligible to or can have efficient use of those type of resources. So that is the concept of smart city. In simple words, we can say that the resources of the city, nothing but the different government department, it must be available to the people of the city for the efficient and effective management of the resources. Now, here it is a technology of designing a city intelligent enough to interact with the government and the citizen. So that is a goal of the smart cities, and all the citizens of a city must communicate with the different departments or resources for effective functioning. So here information is shared among different departments and to the citizens. It makes the system more effective in finding the solution. So what is the goal of this? So here it is to find effective solution in case of any problem with any of the resources of the city. That is the goal of smart city technology. Now in the next slide. Here, the citizens' participation is also important factor. And to make effective the smart city concept, the people or citizens of particular city has to take part in that particular system or in the particular concept of smart city. And it can be a public transport or IT connectivity, water and power supply, sanitation, solid waste management, and e-governance and citizens participation. These are all the parts of smart city. Here the main concept is the all the resources, like these are the different resources, must be available to the citizens, and here citizens participation is also an important factor to have to find a solution to different types of problem in the city. Now in the next slide, say this is how we can understand with this diagram. So smart city means IT connectivity are connected to this, and power supply, sanitation, water, and public transport. See, all these departments or any sectors will be come together to find a solution to a particular problem in the name of or in the technology smart city. Now, adding more, how can we achieve this? Here, this can be done by adding more cameras. They are AI enabled cameras. So government effectively monitor the crowd density, cleanliness of the public places, movement of registered vehicles, and so on. So by installing AI-enabled cameras at different locations of the city, so it is possible for the concerned department to monitor the crowd or density of the crowd, cleanliness of the city or in public places, and movement of registered vehicles. See, these are all possible by installing different types of cameras at different location of the city. Now, data collected from different devices will fed into an online platform, and government access these data and monitor how city is functioning in real time. So actually, once all the data collected from different devices, for example, here is CCTV. So this data is collected from the CCTV and it goes to the different concerned department or different data and through online platform. So with the help of this, the government department or a government can access these different types of data and they can have a look at how city is functioning in real time. Next one is this information can be sent as a wireless signals across a network of sensors nodes to a centralized computer for further analysis. So what the data is collected from the different devices, it goes to the department and from here it go. I mean, all these can be processed through a type of wireless signal across the network sensors. So here all these are nothing but all the signals or the data goes to the department or to the government through different devices in the form of wireless signal, and it goes to the centralized computer where the data analysis can be done or further action can be taken by looking at these type of data. It results in effective communication among different departments, effective management of cities. So because all the different departments of the government are connected to these type of system or smart city concepts where each and every department will be having the data recorded from different devices, and with the help of that, so effective communication takes place among different departments. And this is one example here in Dubai. There are 50 smart services from 22 government department sectors are connected from for effective management of smart city concept. Here they have a different apps for different services like booking a ticket, booking taxi, pay your bill, etc. See, this is one of the example for smart city technology. Now let us see some other examples here. So public street lights darks and dims when there is a traffic or when there is no activity. So this is by using sensors. So when there is a density of the population or where there is a crowd or where there are some citizens, then the light it will glow or it will be darkened. And when there are no traffic or no data, then it will be dims by itself automatically through sensor. This is one of the example. And looking for a free parking spots. So this is one of the important application. So through this smart city concept, it is possible for the citizens to look for a search for particular free parking spots. And the smart building uses sensor to detect earthquake and tremors and then warn nearby buildings. Another advantage of this smart city concept through sensors. And the smart tunnel. Another example is also use wireless sensor to detect any leakage or congestion in the tunnel. This is very important concept here or very good example. Like the smart bridge. A smart bridge uses wireless sensor to detect any loose bolt or cable or crack. So any type of damages can be detected through this concept. So these are some examples for smart city concept. Now let us move on to next slide. Here we are going to talk about next technology, that is cloud computing. So what is cloud computing? Now here a cloud computing is an emerging trend in the field of information technology or IT, where computer-based services are delivered over the internet or to the cloud. It is accessible to the user from anywhere using any device. See, this is the definition of cloud computing. See, what is a cloud computing? It is a type of technology where the user can access different types of services through a cloud. So, either he can access remotely. So that is the definition of cloud computing. Now look at the diagram here. Is a cloud is a one mechanism or a system. So it's a cloud computing where if you look into that, one of the device is this, another device, all these comes under one device, and the services of all the devices can be accessible by different users at different part of the world. That is the concept of cloud computing. So here the resources, it can be hardware or software resources, are provided by companies called cloud service provider, usually charged on a pay per use basis. What is the definition of again here? It says that so the resources can be hardware or software can be accessed by the user through provider. Service provider means cloud service provider. They are the one, they are going to provide different types of services and usually charge on pay per use basis. So whenever you want to use it, you pay only for your usage. When you are not using, you need not to pay for that. That is the concept of cloud computing. So that is the meaning of charge on a pay per use basis. Second one is on-demand delivery of IT resources via internet with pay-as-you-go pricing. Same concept here, on-demand delivery of IT services. So whenever we demand, we can access those services, or whenever the user demands, so these providers provide the respective services to the user on pay-as-you-go pricing. I mean, you pay only when you use a service, or you pay only for the time duration what you have used the service, or different types of service. That is cloud computing. Instead of buying physical data centers and servers, you can access the technology services such as computing power, database, etc. cloud service through cloud service provider. So what is the concept here? They are the one providing different type of services. To provide those services, those providers, cloud service provider, must have a physical devices with them, and they have to maintain their devices effectively. So at the user end, the physical data centers are one who want to make use of a service. So we should not, the user need not to buy our physical data servers, or maybe any of the different software like database, devices, anything. So at the user level, at the user side, the user need not to buy any physical or any hardware, software for their particular services, because these devices, either hardware or software resources, are available at the cloud service provider. They will be having their own physical servers, hardware, software, apparel, and so on. They are going to provide services to the user on pay-as-you-go pricing. That is a definition of cloud computing. Now, all the data security, maintenance are taken care of by the provider. User of the company is free from these things. So what is the benefit for the user at their end is, as the physical servers is not available at the user's end, so all the maintenance and security concerns will be taken care of by the cloud service provider, and it is users will be free from all these things. Now it offers cost effective on-demand resources. So what's the meaning of on-demand resources? Means whenever we can demand, they are going to provide the service for us. That is on-demand service, and it also very cost effective. Now let us see the examples of cloud computing in industry. They use for wide range of cloud services such as data backup, disaster recovery, email, virtual desktop, software testing, big data analysis, and instantly scale and deploy globally in a minute. So what's the advantage of this in the industry? We can use this in different types of industry where the user will be benefited more. So that is the example: disaster recovery, email, virtual desktop, virtual server, software testing. Here, if I say software testing, and the software testing can be done in the service provider platform itself. Here, the user need not to have any sorts of hardware resources or software resources. And healthcare centers in the department, more personalized treatment for patients. So it is data analysis again. With the help of this, it is possible to give a better treatment or diagnose the patient in a right way. Now, financial services, real-time fraud detection and prevention. Another advantage of this concept, cloud technology, games, providing online game services to the world. And here, the few of the cloud service providers are Microsoft Azure, AWS, that is Amazon Web Services, and Google Cloud and IBM Cloud. These are the different cloud service provider. In the next slide, we will see another technology, that is grid computing. So what is the grid computing? A grid is a computer network of geographically dispersed and heterogeneous computational resources. So grid computing, it is also a type of network. But here we are going to connect different devices, heterogeneous resources. It may be hardware, software, different types of devices are connected to a network, and they are geographically dispersed, maybe at different locations. In simple words, we can say that a grid computing is a type of network where we are connecting different types of devices and different types of devices at different locations. That's the definition of grid computing. And its primary focus is to provide services. How we are having cloud services, it is also to provide services. But a grid is a more application specific and creates a sense of a virtual supercomputer with enormous processing power and storage. This advantage of this is going to provide enormous processing power and enormous storage for the users, and it is application specific. The constituent resources are called nodes. Here, what are all the resources we are going to connect to this grid network, it is called as nodes. And these different nodes temporarily come together to solve a single large task and reach common goal. And it is also to provide services to solve a particular problem or a specific problem, so that all the nodes, if I say all the resources, they will come together or communicate effectively to solve a particular type of problem to get a good solution. That is the goal of this grid computing. Now, in grid computing, multiple computing nodes join together to solve a common computational problem. That's what I have seen in our previous slide. It's going to solve a common problem. It can be of grid, can be of two types. One is a data grid. So what is data grid? It is used to manage large and distributed data having required multi-user access. It's going to manage the data. And CPU or processor grid, another type where processing is moved from one PC to another PC as needed, or large tasks divided into subtasks and divided to various nodes for parallel processing. So what is the meaning of this here? So here in CPU or processor grid, here if there are more than one or two nodes in a network, so suppose any problem to be solved, and this particular problem is divided into subtasks, and these subtasks are moved to some other nodes for processing, and suppose is going to divide the various problem into some of the smaller subtasks. All these tasks are moved to different various nodes. It is a concept of parallel processing. So these two types of grid computing, data grid and CPU or processing grid. In the next slide, we will see another technology, that is blockchain. So what is a blockchain? So here, a blockchain technology works on the concept of decentralized and shared database, wherein each computer has a copy of the database. So it is also a type of network. What is a blockchain? It also forms a type of network with limited resources or limited computer. So it works the concept of decentralized. Means what do you mean of decentralized? Here all the data and communications are not in one particular location or not centrally maintained. Decentralized means here all the data or resources or information are shared among different nodes in a blockchain network. So a block can be thought as a secured chunk of data, valid transaction. So suppose what the meaning of transaction here? Suppose imagine that if there are five people in a network or five people in a blockchain network, so all the five people will be connected. So the here each transaction is called as a block. It is nothing but a block, and it is a secured chunk or secured block. So here each block has some data called its header, and which is visible to every other node, while only the owner has access to private data of the block. Here every transaction is recorded that is nothing but a block. And in a block, in the network, if there are five users in a blockchain network, all the five users will be having the information about the different transaction or about nothing but a block. So each block will be having the header part of it, and only the concerned person in a network can access these type of blocks. That is a type of security, and such a blocks form a chain called blockchain. So these type of blocks, they have come together to form a chain. It is called as blockchain technology. Here nothing but a blockchain is a network of limited resources, and all the users or all the nodes will be informed in all on each and every transaction takes place in a network. And here each and every transaction are recorded in a place that is called a block, and all the blocks comes together to form a chain. It is called blockchain technology. Now it is a revolutionary technology, tends to provide more safe and secure transaction. This is the plus point of blockchain technology. Each transaction is recorded in a block. It forms a chain of block, what I have told you in my previous slide. It is a digital ledger or diary. So what is the meaning of diary or ledger here? Say if you look at the bank ledger, for example, so all the transactions are recorded in a ledger or in a diary. That is with the example of a bank. Now with respect to blockchain here, all the transaction as carried out in a network are recorded in a digital ledger, or is called as a diary, and it is distributed across the network, means public diary. I mean all the transactions are recorded and it will be shared among different users in a blockchain network, and these transactions are encrypted with a strong algorithms and cryptography. Obviously is going to provide a security by means of cryptography or power of a strong algorithm. Here each user is provided with a public key and private key. Public key is for all the users in the network, and private key will be with the owner who has shared the started transaction. So this is the in cryptography works with the two types of keys. One is public key and one is private key. Public key will be available in the network with all the users, and whereas the owner has only the private key who has the one started transaction. Each transaction is validating by all the users in the network. It avoids hacking the transaction. So what is the advantage of this here? All the users in the network will be aware of this or shared these type of blocks or this type of transaction. I mean each and every transaction will be known by all the users so that hacking can be avoided. It is a transparent, unchangeable, decentralized digital diary. So it is all the data are not in a one place. It will be all the data transactions are shared by among all the users. That is the reason we say it is a decentralized structure. It ensures trust, security, and safe data transaction in the network. This is the advantage of blockchain technology. Cryptocurrency is an example. It uses blockchain technology. These are the example for cryptocurrency is one of the applications of blockchains. Now let us see another applications of blockchain in digital currency and in healthcare. In healthcare, better data sharing between healthcare providers would result in higher probability of accurate diagnosis. This is the one of the applications of blockchain in healthcare industry and in land registration records, and to avoid various disputes arising out of land ownership claims and encroachment, so on, to deliver cost effective care. Another application, and banking, media, telecom, travel and hospitality, and even other areas where we can find applications of blockchain. Students, so far we have discussed about few technologies in the field of information technology. So let me continue my discussion in my next class. Thank you so much.